Hi, welcome. I'm Nick Ruda. I am a Principal Product Marketing Manager here at AWS. I cover data lakes and analytics services. I'm really glad you've joined us today to talk about these topics. What the purpose of the session is to be a general introduction to the AWS portfolio and some of the advantages we think it brings our customers based on what customers have told us. It's not a deep dive into the technology. You won't see architecture diagrams. You won't see lines of code samples. If you've come to that, you're in the wrong place. But if you are looking for a general introduction to AWS services in the analytics space, that's what we're here for. And thank you again for joining. So I want to start just with a quick level set. What is the point of analytics? And obviously the idea of analytics is to get answers, to get insights from the data within your organization or other data you can access. We want to do that as efficiently as possible, though. We want to make it cost effective and we want to make it fast. So AWS recognizes that there's a couple of advantages we have in this space, and we really kind of build with the concept of a cloud data lake as the foundation for our analytics portfolio. We want you to spend less time on plumbing your environment, less time like building the infrastructure, less time purchasing hardware, stringing it together, operating systems, all that undifferentiated heavy lifting. What we do want you to do, though, is pick from the portfolio the pieces you need and stitch them together into a solution that fits exactly the requirements you have for your environment. Our portfolio makes it really easy to build the infrastructure you want and tie it together. It makes it really easy to tie together the different analytics components and do so very effectively around a data lake. We do it on a secure infrastructure that includes things like Amazon S3 and Amazon EC2 for storage and compute respectively. And we make sure that infrastructure is incredibly secure with all kinds of different security capabilities, encryption, logging, authentication, etc. Everything you would need is a very comprehensive security portfolio. We also have a very complete analytics portfolio. The idea here is that you have AWS as your one-stop shop for everything you need, every different variety of analytics. And there are a lot of different approaches to understanding your data and getting value out of your data. We want to be able to offer all of those to you from one vendor in a tightly integrated portfolio. That said, we also want to make sure we're being open and that the platform is future-proof. We build on common standards, common formats, common data languages and programming languages and analytics tools. And so from that, you can bring your own tools. You know you are future-proofed and not locked in any way. The last piece we hear as one of our common advantages is really the unlimited scale of AWS and to be able to not just scale, but do so cost effectively. And because you can do that and add resources on demand and turn them off when you don't need them, you can build a really agile environment and be able to answer all the different questions you have in your organization. So what I have here is a very complicated stack. It shows all the different pieces, but we're going to walk through these and you're going to get to mix and match the elements that you need most for running your analytics. What I want to get across though is that we have both the breadth and the depth, and that this is a tightly integrated stack. These tools will work together out of the box and very simply do what you need to do, and people often build architectures that involve many of these different components together. Starting at the bottom, first thing we want to do is get data into your environment, and you can see here different data movement and streaming services listed. We'll talk about these again in a moment. Above that, you talk about tools that can help you manage your infrastructure. How can we better secure the environment? How can we allocate the right resources? How can we understand and catalog the data and make it easy for discovery? And then we have several services that play in that space. Above that, well, that's where the fun stuff starts, and these are the different analytics engines themselves. Whether you want to do things like data warehousing or big data processing or log analytics or streaming analytics, if you need to do ad hoc and interactive queries of your data lake, all of these come in at the analytics layer. And again, I'll walk you through the different services that come in there. And then at the top, you can see things we do where you can access new data if you need to complement the data that's already within the boundary of your organization. You can see we have dashboards and reporting and BI visualization type tools available for you, and quite a few ML and AI tools. They'll be outside the scope of this talk, but there's plenty of other places where you can learn about those as well. Now, this portfolio is not new, but it's grown over time. Some of the services like EMR date back as far as 2009, Redshift 2013, but that doesn't mean they're last generation tools. What it means is we've had many years to build and innovate on that and learn from our customers. What do you need to do? How can we make them better? And they're very mature, robust, complete, comprehensive tools to serve your needs for analytics. Now, let's work our way through. I promised we'd talk about each part of the stack in order. Let's start at the bottom. Let's start with data movement. Before you can do anything, what we need to do is we need to load data into your data lake. We're going to use that data lake as the central repository for all your analytics needs, and to do that, we need to populate it with your different data sources within and without your organization. So that data lake, again, it's going to take down the silos you typically have where data lives in an individual database or data warehouse where it's coming from a particular source where you have to look at it individually. And what we're going to do is we're going to put it all together into an S3 data lake. And we have really comprehensive options to help you load and populate data to that data lake. The reason we have many is we want to have the choice for you to find the most efficient tool. Efficient in terms of time it'll take to load the data. Sometimes if you have a small amount of data, network connection's great. But if you have a ton of data, maybe a larger appliance is necessary to get it there. We also want to reduce the cost it takes to get that data in. And this probably isn't a one-time operation, it's probably ongoing. So starting with some of the choices, we have hardware appliances, which can be shipped or actually driven to you. And these are our Snow family of products, things like Snowball, Snow Cone, Snow Machine. Depending upon what level, what amount of data you need to move, we have different tools that'll help you physically move the data into our cloud and into our S3 data lake. We can also connect with your existing storage devices. So we have a storage gateway service that'll connect to them, or we can connect your network with Network Direct Connect, and then you can load things across the wide area network to the data lake in AWS. We can use access faster to edge locations with S3 transfer acceleration. And as I said, we can support ongoing streaming data. We can do this with tools like Kinesis or IoT Core, which would give you then access to like machine-generated data for your IoT environment. All of these different choices are available. You may use, again, a variety of these depending upon what your source is and how you want to load it, how often you need to load it, and how much data you're working with. So that covers getting data into the data lake. Getting it in is just the beginning, though. We need to think about where are we going to store that data. We need to figure out how are we going to organize it. How are we going to manage the data? How do we secure access to it? Just because it's in AWS doesn't mean we want everybody to have free access to it. What we want to do is have controlled access to it. Make sure we're in compliance with your security policies and your different roles, who can see what and why. Not least, we want to be able to prepare that data for analytics. Sometimes it's good to look directly at the raw data files, but generally what we see is that customers want to organize their data. They may want to transform it, they may want to join it together, they want to move it to columnar format, different ways to make it more efficient to analyze. So if we look at that data lake picture, what we're really doing here is we're combining different types of analytics around that central data lake. We might be combining data warehousing, varieties of analytics, machine learning, whatever technique you need. What we want to do is we want to break down the different silos you had, where traditionally each one of these disciplines would have its own copy of the data. It's much more efficient to have a central repository of that data and access it all together and bring your compute resources as you need. Bring your analytics engines as you need them. So we're going to build that data lake, and we're going to make sure we store that data securely in S3. We're going to do it in standards-based formats, things like ORC or Parquet, and we're going to do it in ones that are like those efficiently optimized for analytics. This way you can bring whatever types of analytics to the data versus vice versa the other way around. It's much more convenient than a traditional approach where every database, every data warehouse appliance, every tool has its own store. Let's bring it together and bring the analytics to it. And let's use S3 as that central platform for it. Now, why would we use S3? Well, S3 is the most popular data lake architecture out there. We have many, many customers running this. And the reasons they tell us they choose it start with some of the traditional enterprise IT values. Things like 11 nines of durability because of the way we organize our data centers. And we have different availability zones in different regions, and we automatically replicate the data between them for you. High availability in those environments. We have SLAs on many of these services, often 99.99% or higher. We have almost unlimited scalability and great cost efficiency on that. We get economies of scale as you store more, and we do so while we're still maintaining 3 copies for you automatically, or multiple copies, however many you set, but across different availability zones in each region you want to be, maybe even replicating between regions. Now, to be efficient here again, you might have some data that's infrequently used. We can move that data to lower cost storage. We can back up and archive it with tools like S3 Glacier. Now, if you want to query it efficiently, maybe we don't need to pull all that data back. Maybe we can use things like Amazon S3 Select or Glacier Select, and they're going to pull just bits of data as you need it and potentially make it up to 400% faster and much cheaper. If we don't need to read all the data, if we can have it organized in a way that we can read it efficiently, that's going to reduce your time and reduce your costs as you go to access that data for analysis. Now, having it in the data lake is good, but we still need to organize it. Here's where AWS Glue comes in. Glue is a capability, a service really, that helps you manage your data by first crawling and discovering your different parts of your environment. It can look at RDS databases, it can read data sources from Redshift, it can read it from S3 or other popular databases. And when it crawls it, what it's doing is learning the metadata or schema for that data. What's in the data set, how is it organized, and it's loading that into a catalog. That catalog is then designed for your users to be able to identify data sets and how they can be used and really do data discovery on what's available in the data lake. That's not all Glue does, though. It also helps you prepare and transform your data. So get it ready for analysis. Like I said, join it together, organize it, normalize it, standardize it, whatever you need to do to get it ready. One of the advantages of Glue is that it's completely serverless. You don't need to manage any infrastructure for Glue itself. You just throw your jobs at it. You can run your ETL jobs into a fully managed environment, and it's going to scale out for you. Often people will use things like Apache Spark on the Glue platform, and that serverless Spark approach is what makes Glue so efficient, but it does it again in a pay-as-you-go type of approach. You don't need to worry about the infrastructure behind the scenes. You just submit your Spark jobs, and they'll run as they need to against your data. So it also simplifies this. Glue can make it much easier to run ETL by auto-generating the code you need to run. You don't necessarily need to program it all yourself. You can use different templates and blueprints for your jobs and organize the way you do ETL for one-off jobs or for ongoing jobs or new data sources, and learn as you go. Now, traditionally, building data lakes was a lot of work. We've had customers running data lakes on AWS for many years, but we're hearing they're having some challenges. Some of those challenges were in setting up and configuring the storage for the environment, trying to figure out how are they going to move the data, how are they going to prepare the data, how are they going to secure the data, how are they going to make the data available safely with the right guardrails on access control, and what types of data within a data set an individual could see. Worse, customers traditionally had to do this per service. So if you're running 3 different analytic services against that data lake, you may have to set up these controls multiple times and have uneven sets of controls on what you can do, how you can restrict access, how you can provide access. That made it complicated. So setting up different security policies per service was really inefficient. And done manually, we're hearing from our customers that often this was taking them months to build a data lake. Well, I said early on, people choose this because they want to easily build a data lake. Let's get to the good bit of analytics faster. We introduced a new service, and it is now GA as of last year, that is called Lake Formation. Lake Formation helps automate and centralize a lot of the process of building a data lake. It gives you fine-grained access control and permissions. You can set different groups or roles, and you can basically vend credentials to people and give them specific access for their needs and how they access that data, how they manage it. Lake Formation wasn't a totally new service. It really builds on the capabilities of Glue. And if you're using Lake Formation, you may jump between it and the Lake Formation console. But it centralizes that control. So you can set up these security policies and use them with things like Redshift or EMR or Athena together and configure one set of policies that applies across all of them. Just like Glue, it simplifies the ingest and cleaning of the environment and setting up that data for analysis. But it also brings new capabilities like machine learning transforms. These machine learning transforms can do things like identify duplicates within your data set and learn, wait, this data actually references that data. Let's drop out one of the examples and make sure that our data set is as efficient as possible. Let's do fuzzy matching of similar things that have slightly different names. And all these capabilities together with Lake Formation really help you simplify your environment. You can reduce the time it takes to build a data lake, typically from months, as I said before, to days, and be up and running and ready to go with a new data lake and bring your analytics to that data, knowing it's secure, knowing it's organized, knowing it's cataloged and transformed and prepared. So we have our data into the data lake. We know about that data lake infrastructure. We know how we're going to organize the data, catalog it, how we're going to make it available and secure it. Now the fun begins. Now we get to talk about the different analytics engines we can bring to that data. And there's many different ways you can analyze that data once it's ready to go in your data lake. So you can provide this to your different users, or you might be one of those users who wants to use one of these particular tools. Maybe it's big data processing. Again, maybe it's data warehousing, whichever tool you need to manage your data in the appropriate way for analysis. That's where we're going now. So let me start with EMR. EMR is designed to be your big data processing and analytics engine. Big data processing really came about as people got more variety of data, more velocity, more volumes of data they needed to manage, and they needed some tools to do that. So the open source community rallied together and came up with things like Hadoop and Spark and different components within them like MapReduce or Pig or Uzi and all these different components that unfortunately, at the time, customers had to manage themselves. They had to track each one of these open source projects. Well, what we did was we created a fully managed platform that brings together 21 open source projects and keeps them up to date. You know, you always have the latest. It's still using open source, so it's community generated, but we make sure that it is stable and ready to go and build it together and greatly make it easier for you to manage a big data environment. We've also made it really cost effective. Rather than having tens or hundreds or thousands of nodes on premise, you can bring your compute power to this with transient nodes and transient clusters if you need to. Obviously, if you have a long-running job, you might want to run in a more permanent cluster. But if we're transient jobs, we can pay per instance per second, down to a 1 minute minimum. And this really makes it very efficient to run big data jobs as you need them, when you need them, and be able to scale that infrastructure on demand. We can scale up, we can also scale down with our auto-scaling capabilities. We have native support for EC2 spot instances. We can also use reserved instances or savings plans. And together these ways also make it more cost effective. We find that customers typically save 50 to 90% if they're using the EMR capabilities and running in a cloud native way versus bring your own big data software and just running it on EC2, for example. Way more efficient to run EMR and use some of its advantages natively. When you need more clusters, you can spin them up in minutes. And when you want to do analysis on that or build a new big data application, we have Jupyter-Based Emr Notebooks. These notebooks are persisted off cluster, and you can use them to collaborate around your big data application. You can use them to develop. You can reuse code bits. You can move them from cluster to cluster as you need to. Even if you turn off a cluster, you can load that EMR notebook then on a new cluster. And this is one way we've made it a lot easier to do that big data application development for your environment. Because of these reasons, we have great industry analyst reviews of the service. You may be a little surprised to see that EMR and AWS is really positioned at the top of the Forrester wave for cloud-based Hadoop and Spark infrastructure. This study is from Q1 2019, but we're looking forward to a future study from Forrester, which will continue to show our innovation and success here. If you're looking to move an on-premise big data environment to AWS, we also have the Emr Migration Program. And I wanted to call this out real quick because we can offer you free 2-day assessment and planning workshop looking at your on-premise big data environment and figuring out how would you re-architect it, how would you make it most efficient to move that workload, modernize it, really modernize more than migrate, and run it in the AWS Cloud on EMR. So if you're interested in that, you can contact us via the EMR Migration Help alias, or you can visit our webpage or /EMR/EMR-migration, and they'll have lots more information about this program there. So that covers big data. Big data is obviously often a prequel step to being able to do other types of analytics, and one of those typical approaches is data warehousing. Gone are the days of having to have a fixed on-premise hardware appliance that was very expensive and hard to scale, inflexible in terms of growth, and very limited. We can do our data preparation in EMR and then use it with the data warehouse. And Redshift is our data warehouse service. We have tens of thousands of customers running on Amazon Redshift, and they're processing over 2 exabytes of data per day. That the volume of workloads gives us a lot of opportunity to look at the different jobs and how they run and make it really efficient. Redshift is the only cloud data warehouse with native S3 data lake support that doesn't require you to ETL data into your data warehouse. You can analyze it directly in place, and we often call this a lakehouse type approach. Obviously, you can run the data in Redshift if you want, or you can store it in your S3 data lake, and with Redshift Spectrum, bring your analytics to that data. Now, Redshift is also the fastest cloud-based data warehouse out there. We see it up to 3 times faster when you run RA3 nodes as your instances for Redshift in your cluster, and up to 10 times faster with a new service feature we call Aqua, which came out. You can read more about that separately. Redshift, as I mentioned, has a hybrid architecture option for how you want to manage your data. You can do shared storage on S3, and that gives you the ability to scale nearly infinitely and bring really high concurrency, be able to add as many types of data warehouses as you want looking at that same data set. Alternately, you can load your data into that data warehouse and have on-instance storage, and this takes away some of that latency and gives you higher speed performance depending upon what you want. We often see customers doing a mixture of these. Now, if you need more scale and performance, we introduced a new feature for Redshift called concurrency scaling recently. And what this does is it automatically adds compute power on demand when you need it. That gives you the ability to not have to predict in advance how big your workload is going to be, but really grow with it as it is dynamically and have that agility as you go. Another advantage of Redshift is security out of the box. Unlike some other options out there on the market, we provide the full boat of security capabilities within Redshift out of the box, no extra charge. Other vendors like to charge a premium for this, which can really add up very quickly. Not least, if you have unpredictable workloads, with that concurrency scaling I mentioned a moment ago, we can offer you up to an hour of free concurrency scaling per day. So if you have short-term peaks, don't worry about that. You're not going to get charged. This is making it much more cost-efficient for customers. In these ways, we see that Redshift is really probably the best cloud-based option out there. Now, we've talked about big data. We've talked about data warehousing. Let's take a moment to move to streaming analytics and streaming data processing. And this is where our Kinesis family of services come in. Kinesis really isn't one service. It's a number of them, all using the Kinesis brand name together. An example for that is data streams. Data streams helps you build real-time streaming applications, and you can use popular frameworks as part of Kinesis data streams. So the tools you're familiar with, we just run them as a fully managed service for you. We also have Data Firehose, which is a capability within Kinesis that lets you collect and load streaming data into your data environment. And we have Data Analytics, Kinesis Data Analytics or KDA, which then helps you process or analyze that streaming data as it's streaming using standard ANSI SQL type commands. So a couple of different options here within Kinesis. It's not just about loading the data, it's about analyzing those streams as well and managing the stream processing and making it efficient for you. Another option here to work with streaming data is Apache Kafka. You might be familiar with Apache Kafka. It's an open source platform to manage real-time and streaming. It handles data pipelines and streaming applications, and it's very popular. What we have done here is we've made it easier for customers. We've introduced the managed streaming for Apache Kafka, or MSK, and given you a fully managed environment. So the idea here is that you can use Kafka APIs, you can use Kafka to load data directly into your data lakes. We can stream changing data to or from different data lakes and be able to manage it that way. We can power your machine learning, we can power real-time streaming analytics. But with all of this, you don't need to manage the infrastructure for Kafka. Just like other AWS analytics services, we're going to provide a fully managed environment for you so you can really focus on spending more time building your applications and not on managing that infrastructure as you would on-premise or as you might if you used Kafka to bring it your own sort of environment. One other thing we're doing around Kafka is we're always contributing back to the open source there. As we do innovations for our MSK, we make sure we add those back to open source Apache Kafka where we can and contribute back to the community. Wrong direction. Another approach for analytics is looking at log-based analytics, and people are again familiar with Elasticsearch as a common tool here. We have a fully managed Amazon Elasticsearch service, or ES, and what this service is designed to do is really help you collect, analyze, and visualize data that could be in log files. It's typically text-based, it could be machine-generated, might be coming from IoT platforms, sensors, what have you. And Elasticsearch is a way to look at that data and understand the patterns in it, try and troubleshoot, collect the data, index the data, analyze it in real time. And to do this, you'll do this to manage your infrastructure. So if you want to better resolve errors faster, we can decide what looks like a normal pattern, what looks unnormal. So Elasticsearch service builds on the ELK stack, ELK, and so it's using open source Elasticsearch APIs. It's providing for you managed Kibana, and it has integration with Logstash. So it's, again, a fully managed service. You can deploy an Elasticsearch service environment in just minutes, and you can scale it up. You can use APIs to scale it if you want. And one of the things we've done with it is also, again, enhance its security capabilities. We want to make sure your data is secure at all times, at rest, in transit. We want to make sure that it's in compliance with industry and government regulations and best practices. And just like our other services, it's really pay-as-you-go availability to Elasticsearch within the AWS Amazon Elasticsearch service. Now, related, but at arm's length, we decided that it might be also helpful to foster a community around Elasticsearch and make sure that it is truly open source. So what we did is we helped found the open distro for Elasticsearch, and this is around really making sure the open source innovation thrives independently out there. It's a fully featured Elasticsearch service in its own right, and 100% open source. It's community driven. AWS does not own this technology. We're helping manage the community and making sure that it's out there for people to use. Anybody can use it, they can modify it, they can distribute it. There are really no restrictions on what you can do with it. But AWS is contributing back to it here. We've added a number of new services to the open distro for Elasticsearch, things like encryption in transit, authentication with Active Directory or OpenID. We've added role-based access control. We've added event monitoring capabilities, SQL support, and other advanced diagnostics. And we've done this at no cost. Our goal here isn't to make money. It's to, again, help Elasticsearch thrive in the open community and to encourage community participation around it. So something you might want to check out if it's a common area for you. Another approach to analytics, and I feel like we've gone through so many already, but is ad hoc interactive analytics on the data in your data lake. So sometimes you don't need a formal approach like a data warehouse. Sometimes I don't need to do streaming analytics, but I want to get answers quickly, and I want to be able to look directly at the data in the data lake. So what we've done here is we've built a serverless approach to being able to do SQL queries directly against data in S3 or data in Glacier, wherever that data lives. We're able to analyze it directly, and you just bring your commands or jobs to Athena and run them as you need to. You can query that data pretty much starting instantly and be ready to go in seconds and get answers as fast as your job can run, and you'll just pay as you go. So kind of pay as you get an answer for queries on that environment. There's really no need to ETL the data. If you want to prepare it using Glue or Lake Formation, you can. But if you want to just look at data natively in S3, Athena lets you do that directly without any other intermediary steps required. So with this, like anyone with SQL skills can immediately begin analyzing their data in the data lake. So it could be a good way to do like exploratory analytics and just discover what's out there. Or you could build an entire application or infrastructure around using Athena as the serverless automatically scaling engine for you. Athena's gotten even better in recent years with capabilities like federated queries. You can look at multiple data sources with a single query, or user-defined functions that let you add new capabilities, new controls to how you do your querying with Athena. So lots of new cool things coming out here as well. And oftentimes it's a great, like I said, light way to start to explore what's in your data lake, start to do analytics. And then if you decide you want to move that into EMR, if you decide you want to move it into Redshift, or just keep your application on Athena. Lots of different choices there as well. All right, so at the top of the stack, we have ways to get new data, ways to see your data, and ways to build machine learning and AI on your data. And the reason you'd want to do that with a data lake is the more data you have, the more creative you can be, and the more accuracy you have in building and training your models. I'm not going to go into your ML and AI service choices here today, but there's plenty of other sessions that do. So let's talk about enhancing your data. We have a new service we introduced recently called Data Exchange. It lets you bring in data from outside your organization. There are thousands of commercial data products from providers in all industries. There's all kinds of free data sets too, different trials for commercial products or public data that you can access via Data Exchange and combine with your own. You can find and subscribe this data in the marketplace. It'll be kept automatically up to date by the providers. And then you can immediately use that data with all the analytic services I've already described. This really removes the friction of finding, licensing, and using third-party data sets for you. Not least, we want to talk briefly about BI and dashboards and reporting. And traditionally with BI, it was hard to scale. There was a trade-off between access and cost. But we introduced QuickSight, and QuickSight is a serverless solution that lets you scale to thousands of users. You're just going to pay as you go, $5 a month cap on it. You're not going to pay for inactive usage anymore. You can also use QuickSight to embed these types of visualization and reporting directly in your applications using the QuickSight API. So one of the things that you can do with this, and is really an interesting direction for us, is serverless analytics. And all the benefits I talked about serverless still apply here. But I've shown here one example, a bonus architecture diagram, showing how we could load data from IoT to our S3 data lake. We could organize it with Glue. We could analyze it in place with Athena. And we could use QuickSight to display AI or ML data that's read via other services directly from that environment. This whole environment then would be completely serverless, all the advantages that brings. We think this is an interesting direction to explore. AWS, because of all these, offers more data lakes and has more customers running their data lakes than anybody else, tens of thousands of data lakes running on AWS from customers like these brands. So just to wrap up quickly, I want to encourage you to take a look at training and certification and other sessions in the summit, learn more, and then prove it. Get a certification for yourself. And I hope this has been a useful introduction to AWS Analytics for you. Be sure to give us feedback and let us know what you liked. You see my contact info if you want to reach out directly. Thank you. Have a great day.